My name is Vincent. I will explain you some problems for the coming midterms. What is calculus? Whenever I thought about calculus, I always thinking about myself standing on the ground of limit. And above me there's a bridge. The left part is derivative. And the right part is integral. And how does derivative and integral connect to each other? This part is called the fundamental theorem of calculus, which you guys all have learned already. So it's like a big picture of calculus. Alright, so the hint for the first problem, which is also a very important key term, is the line tangent. Whenever you see the line tangent, you should know the standard form for the line tangent. Y minus y1 equals to k times x minus x1. So x1 and y1 is just one single point, which you can get easily by plugging into x equals 2 back into the equation. And as for the slope, k, which should also be relatively easy. When we see the word slope, you should realize it's asking for the first derivative of the original function. Now we take the derivative of the original function. We have f prime x equals to 12x squared minus 3. We plug back into 2, we'll get 45. Let's extend the page a little bit. Alright, now let's find the point. When x equals to 2, what does y equals to? Easy. f2 equals to 4 times 8 minus 3 times 2 minus 1. So I have 32 minus 7 equals to 25. Now we have everything we need. We need to plug back into the standard form. Y minus 25 equals to the slope, which is 45 times x minus 2. If we extended this, we would get the right answer, which is 45x minus 65. Question number 2 should be somehow easier than the previous problem. You should recognize this form. This is limits. And all this question is asking for is the derivative of cosine x, which you should know is minus sine x. So the answer is B. Just be aware that this is sort of like a conceptual understanding of calculus. And as I said in the previous slide, limits are really the ground of calculus. So be careful. Alright, for number 3, I have no clue what's happening. For number 3, a particle starts at time 0 and moves along a number line, so its position. At time blah blah, and now we have a function, and the particle is moving to the right. So when does the particle moving to the right? You should know is when velocity is bigger than 0. We have position graph. How do we get velocity? Differentiation. Take the derivative of the original function. If you take the derivative of the original function following product rule, which you should all know very familiar, all of you guys should know very well, you should get this answer times 4. Then you should analyze the velocity function Doing so, you can make a sign chart to 5. That's a 0 for the function. You have x minus 2 square, t minus 5. This is always positive, and when t is bigger than 5, it's positive, otherwise it's negative. And the product of this should be negative, negative, positive. So when t is bigger than 5, the particle is moving to the right. C. Alright, question number 4. Forget about the answer. Oh, I can't erase it. Interesting. Alright, question number 4. Now I erased it. So we have a function. It's asking for the minimum value. So all you should know is from negative to 0 to positive. It's like a smiling face. It's the happiest part of calculus. So we need to take the derivative of this, which is, again, product rule. X times 1 over x plus ln x times 1. So you have 1 plus ln x. This looks terrible. When this equals to 0, ln x equals to minus 1. Algebra. So now what you should do is, you need to understand ln x is e to the power of minus 1. X equals to e to the power of minus 1. That's by definition of natural log. And again, we should know the function goes from negative to 0 to positive. If you graph in your calculator, you get something like that. So the answer is A.